Can you hear me now, clearly?
Very clearly, very clearly. All right, thank you. Please carry on.
Oh, sorry, I lost my electricity, so I'm using my data and it's slow. Things everywhere is dark. I don't know. My data is so slow. So just bear with me. So I'll proceed. I hope you can see my screen.
Yes, we can.
Um, so let's move on. So testing is important, and I think it's a no-brainer why testing is important in the life cycle that we have been coming all this way, because we want to check for quality. We want to make sure that all the functionalities that are in place in our software now, it matches the requirement that we had gathered from our stakeholders. And also, when we just give the users the product without testing, we'll have so many defects and it will be costly. So testing helps us in cost reduction, to mitigate a lot of risks. It also help us enhance our customer trust, because they know that whatever we are giving them is well tested, and also for security and compliance issues. So we want to make sure that our system is strong enough and it's also compliant to the different standards, according to the different industries that you might be developing the software for. Okay, so the testing also has its life cycle, its internal life cycle that I basically teams follow while doing the testing. Now, after developers have developed our system, we have our product, we have something that now we want to take it to the user, we want to take it to the market with the users involved. So we start by now the requirement analysis. This we want to gather requirements for our test cycle. We want to understand our functional and non-functional requirements that we have been dealing with. And in this phase now, we do activities like reviewing our business requirement document, the document that we created in the first phase. Together with the stakeholders, we want to identify which requirements are testable, which requirements do we want to test. Remember, during our first phase, we had something called a requirement traceability matrix, and it was just like a document that had requirements that will during the beginning phase. This requirement traceability matrix, it has the requirements that we might want to test after, so that it can be you can trace the requirement to the specific test. You can test a specific requirement to a specific test, so that you can see that that requirement is being fulfilled well. And then after that, we go on to the test planning. You have to you have to plan in terms of the scope that you want to cover, the schedule, the budget, and things like that. You also have to select tools, different tools. You have to see whether you're doing a manual or a automated testing or both. Also the roles, and maybe also but all those internal things, you want to also plan that before proceeding with the test, so that you know the tools you're using and all that. And then maybe what you come out from this phase, you come with a clear plan, a clear test plan, and a clear test strategy for your team. And then now you go ahead to create the test case designs. So after you have planned, now you sit down with your team, and then you create test cases. So basically, a test case, let's say it's like specific conditions and steps that you want to check. So these are very specific issues that you want to check let's say for example of a test cases can be as simple as verifying that when someone puts the username and password and it's correct, it gives the correct processes after that. And when they give the wrong password, it should give the correct response. So a specific, now you come and design these specific test cases that you want to test. And then after seeing all the specific cases in terms of, let's say, login, you want to test the login. um, it should be very specific, maybe in terms of the application should display a specific error during a specific point. You write all these test cases. Most of these test cases are done manually, and some also can be automated in other cases. And then we're going to see also about all that manual and automated testing. So these are just basically the steps that SDLC that someone takes. And then now you set up the test environments. We have different. You have to have like an environment where you're going to run the test, which is not like your production environment, which is not where the users are going to be seeing. So you set up your environments. Maybe it involves setting up some network, some servers, some installation, and the test environment should mimic the environment that the users are going to be using, so that when you run the test, it's like an environment that is very similar to the real environment in terms of the servers, the service, the devices, the infrastructure, and things like that. And then after setting up your environment, you proceed to execute the test, whether it's manual or that is now you are testing the test cases, whether you're automating them using some tools. And then you detect, you continue tracking the bugs now. And then now you move to close the testing. So this is basically the SDLC, which is like an internal phase for the software development life cycle. So let's move. So this is an example of a test case, a very simple test case. We've said that test case is very specific, so that, and sometimes it links to a specific requirement that we recorded in the analysis phase. So a test case has like these different components. We have a test case ID, which is good for tracking, and also just organization. So because we have like tools that help us manage these test cases. So have the ID, we have the description, which here it says it's test login with valid username and password. So we want to just test this specific case. And conditions, we have the conditions for the test case. The conditions are user account must exist with credentials and the app must be working. The test data that we need the username and the password, the steps. So the user will click the application, the browser will enter the username, just like that. We also have the results we're expecting, the results that we will actually get during the test, and then whether it is passed, and then some remarks on that. So this is our typical simple test case look. So when we are talking here about test case design, you have to sit down with your team. Now after capturing the requirements you want to test and whatever you want to test in the planning, you now develop such test cases for those requirements. Now you'll move forward with these test cases, whether you want to do them manually then or automate them. So these test cases can be many, because varying on the many requirements that you want to test. Maybe you want to test whether when someone posts something in a form, like when they like a user enters something in a form, those records should be stored in the database like successfully. So specific test cases that you have to write and then track them and see the actual results. uh, yeah. So the tests in this phase, they can be categorized again. Remember the way we categorized our requirements. Also, the tests can be categorized in also categorize our requirements in terms of functional and non-functional requirements. So our tests can also be categorized in terms of functional and non-functional. Remember, functional is dealing with whatever the system is doing, and then non-functional is now in terms of performance, security, usability. So functional tests, we have tests like unit tests, integration tests, system tests, and acceptance testing. These are the common functional tests that you're going to come across. And then now the non-functional, so security, usability, performance. Yes. And then we have a special type of tests that is called shifting left. So that's where now DevSecOps comes in. When you hear things now like static analysis, security testing, shifting left is about security and it's about detecting bugs early in the software development lifecycle. So that is now a different area of testing where we integrate mostly security testing and the early stages of development. But now we want to focus mostly on these tests here: unit tests, integration testing, system testing. This is what we want to focus mostly on that. Okay. So generally, this is just techniques in testing that we use in IT mostly, in security, in different tests that you want to do. It can either be a black box testing where you focus on inputs and outputs without the knowledge of the internal code structure. So we interact, like when a user is interacting with a system, they don't have the knowledge of your internal code structure, like the way maybe a developer knows. So black box testing is when now we are testing the system from that point of view. We don't know whatever it goes inside the application. So it's like a user would interact with the system. And then white box, this is from a point where you, maybe from a point of a developer, you as a developer, you know the way you have created your functions, your libraries. So when you do a testing, that will be like a white box testing, because now you just want to validate all those things are working well and you have the knowledge of the code logic. And then the mix of the two now is called gray box testing. So these are generally the testing techniques. Um, okay, so let's look at unit testing. The first type of functional testing that we come across. So unit testing, this basically tests the smallest components of code, but ensuring each piece functions correctly before integrating. The smallest block of code, like your function, a specific function, maybe a function that multiplies something within your code, within your Python, within your Node code. That smallest unit, you want to make sure that it is working well as expected. If it's a function that is supposed to add, it is adding and is giving the correct results. So let's say mathematical functions, business logic. Maybe there's a function in your e-commerce system that maybe calculates discounts in your cart. You want to make sure that that specific function, it's calculating the discount well without maybe overcharging or whatever. specific functions, maybe for, let's say, email. You want to make sure it is a function that is validating email is working well. So, the way maybe, and it's specific, some of these are specific to your programming languages, because it's down to this very, very smallest units, those classes you write, those functions. So in unit testing, you take one of these smallest units, and then now you test it to see that it's working well. Uh, so you identify the unit, the same way said you write the test case, and then mostly this can be easily automated because they are at the lowest level, and there are very many frameworks that can help you um, automate such cases. You also have to check the dependencies. Maybe these functions that you want to test have certain dependencies. You have to test. You have to see what these functions depend on, so that when you're testing, and then you can run automated tests, and then you review the results. So this mostly will include maybe it will include developers, because I've said it's the most basic, the functions, the classes, and then also automation engineers, and you're going to be automating it even in your CI/CD pipeline, using there are very many tools that can help us do that. So there are tools and frameworks now that's specific to, maybe you're using Java, you're using Python, JavaScript, C, or also cross platforms that goes across different languages. You can include this in your CI/CD. Most of them integrate into your CI/CD pipeline to run automated tests to check such simple functions and such components are working as expected. So these frameworks will help you write the test cases and integrate them seamlessly into your pipeline. So anytime it is easily testable, like automated using your pipeline, and you can maybe tell it how to test during which commits and things like that, so that the functions as different small functions that now come together and form our complete system. Want to make sure that they are doing the right thing to automate and write these test cases. Okay, so let's move to the second test. Also under the functional tests, which is they go to be part of a bigger system, or maybe a software that has to go and work with other systems in the bigger picture. So we want to see that the interaction between the modules and they function well, and they are integrating well with other systems. So we have basically how this works. We want to identify the modules for interact with the database, because the whole login module works with the credentials that are being stored in the database. So we want to make sure maybe in that level that integrates well. I want to make sure maybe the backend integrates well with the front end, and just in basic levels like that. So you have to plan and
Hi, Viola. Sorry, I'm not sure we can see your screen.
okay, let me reshare that. Sorry.
Okay, cool.
Okay, so with integration testing, so you have said you want first to see what works together. You want to see what you are testing. What is your database with your backend, your front end with your backend. You want to first know to identify those things that are integrating before you do the test, and then you want to plan also the integration strategy, whether you're integrating um, all the modules at once. Are there different integration strategies that top down, bottom up? And then after that, now you prepare your test data. You want to see which data you're going to use, whether it's the login details, and then after that, now you move on to execute your test, and also now log the issues that you have found, so that it can now go back with maybe to the developers. You log the issues, and then now you continue testing. So integration testing is now that type of test. Now you want to see that this module is created. Maybe let's say example, let's say like that's the login and the database. Let's say in an example of an e-commerce website, maybe you have the shopping cart, you have the payments gateway, this is like the modules, the inventory. You want to make sure that these modules integrate seamlessly. Even it can be in terms of, we said, APIs. I want to verify that a web application sends the correct data to the backend. So the different types of how the different modules interact with the system. You want to make sure that they are working well. So the benefits of this test, it ensures combined functionality. Yeah, because now when we have checked how all these things integrate, we can actually say that our system is working somehow, and then identifies interface issues early. Because let's say an example of our e-commerce website, we're going to identify some interface issues when you are trying to see maybe if the inventory and the shopping cart works well. You're going to get some interface issues there. You're going to reduce some system level failures, and then build confidence before you do the actual system testing. Then some challenges you're going to get here. It can be hard to isolate issues, and then complex dependencies. Maybe the system is very complex. The modules are very many that you want to integrate. And then it can be very time consuming because you have to actually understand well the system and other things that the system might affect. And then it also requires a strong team communication within your developers, the testers. It also requires good planning and good understanding of the system, uh, uh, so that the integration testing can work. So you look at different tools. We have different tools that you can use for integration testing, like Postman. When you want to check your APIs and how they're integrating and services, you can use tools like Postman, Rest Assured, this Karate for Java. So these are different tools that you can use now to check in terms of APIs how they're integrating, and then when you want to do some automated integration testing. Also, there are different frameworks that you can use to also check in terms of now automating the integration testing, there are different frameworks that can help you specifically automate this so that you don't have to do it over and over again. But automating tests, it's a bit, most of the team go for manual testing with a bit of automated testing. And unit tests, the one that we have discussed previously, is one type of test that is easy to automate because it's easy to check if a function is working well, or whatever. But maybe something like integration testing, teams might choose to, let's say, go with a manual test instead of automating it because it might be a bit complex and you have to learn of the whole ecosystem of the system that you are creating. So maybe you might choose to go for a manual test. And then also it can be done also in CICD tools. So different you can different CICD tools also offer you a way of integrating like test suits for each commit to check such to check for integration issues. So you can either do it in there are tools for APIs, there are automation tools, there are tools for CICD that can help you check your the way your modules, your components are integrating together. And then this is the most common type of testing. We have the system testing. So this is basically the end-to-end validation. Validates the complete integrated software application against specified functional and functional requirements. So now you have done the unit testing. You've checked the basic components. You've checked how different modules and different features interact. Now we want to check the full system. We want to do a full system testing and check if against all our most of our functional and non-functional requirements that we have captured. So it also works the same way that we had seen. You prepare your test environment that mimics your production environment. Maybe let's say you'll have your production server where the users now are going to be using. You can have now other servers now that mimic that environment, your staging environment, and other different, according to the way your team is set up, other different test environments for different teams. The QA might have maybe their own environment. The security team who are doing specifically security testing might have also their own server to do, and all this they mimic the final environment. So setting up these environments, then also you have to define your test cases. You have to execute a functional. Now you go ahead and execute the functional test. You execute the non-functional test that deals with performance, usability. Then also you also have to log the results. And then now we'll see something now after now regression now here deals with now ensuring that new changes do not break. So after you fix a bug, you want to make sure that that fixing does not break whatever was there. We're going to also look into regression testing in deep a bit. And then now you have to generate reports for the stakeholders of what you tested, so that when you're going to now move ahead to deploy the system, you have all these reports and to show that your test passed according to the threshold that is required. So this validates the complete system. It detects workflow issues. We want to see that maybe example of an e-commerce website. We want to see maybe a specific workflow that's supposed to have for a user, maybe a specific journey. We want to see that it happens seamlessly from beginning to end, and someone can do a specific thing well from beginning to end without issues with the specific workflows that different systems have. And then it also increases confidence in our users. And then it can be complex. It can also be resource intensive. All those environments that you need to set up. You may need to have even one-on-one meetings with the users, the direct users and the stakeholders. So it can be also resource intensive to do a complete system testing. So we said you'll involve your product owners, you'll involve the developers sometimes, the testers, all those will be involved in your system testing. You want to check in terms of everything works well. If it's maybe you are developing a system for a hospital, you want to make sure that these journeys, user journeys, maybe you want to book someone from the time they come in, they log in. You want to make sure it goes well until the time maybe they are fully booked. So this might even sometime take it might take a long time, and it's again I've said it's want to verify that everything works well. So we have different tools for this type, which are very mostly used. You'll hear mostly about Selenium, which is open source, and this will help you mostly automate such test cases for system testing. Tools also like Cypress and Test Complete will help you test for functional testing end to end. And then we have test management and reporting. We have tools that are specific for helping you manage your test cases. Sometimes you need a tool that not automate your test cases, but just manage them. So automating is something different, but test case management, where you store all those test cases that you have written. They can be many because you have so many scenarios that you want to test in your system. So you want something to manage each and those test cases for login, for database, and then you have your IDs for each test case. So such tools are mostly this Zephyr and TestRail and also Qtest are common. And a tool like Zephyr, it is integrated with Jira, and Jira is where you can store your requirements and track your issues. And then Zephyr integrates with Jira, so you can now you have linked your requirement to your test cases. So Zephyr is for Jira. Now you can link your requirements in Jira with your test cases, and it helps you manage your test cases and track the results. And we have for mobile application testing like Appium, and yeah, this one is Expresso, so it can help you test for specific mobile apps end-to-end testing for iOS and for Android. Okay, so we'll move on to the next testing, which is acceptance testing. This is still under functional testing. We want to validate our user needs. So remember we said our user needs are what specific users needs from our system. So maybe in terms of e-commerce, our customer want the user to be able to purchase, to add something to the cart, to make a wish list or whatever. So specific user needs, want to make sure that they are met, and that the user says, actually, yes, I accept that this is what I want my system this is what I want my system to do. So this is what I had envisioned my system to do. So that is what basically acceptance testing is. It is satisfactory to the stakeholders. So we want to make sure that we confirm all requirements from our business requirement document that we had from the beginning. We define our test cases. Again, you have to write whatever you're testing. You have to write the expected, what you expect from that case, what you are testing, and then you later on come to write what you actually got and the remarks. You have to design these specific test cases, and then you have to prepare the environment again. If you have to prepare maybe servers, you have to do that just the way we saw the specific steps. And this will involve now everyone, again, your product managers, the end users. You'll have maybe to sit down in a meeting with the end users and go through the system well. Say, now let's create a user, let's log in, let's create an account, and they'll tell you, this is what we meant here, this is what we meant here, and then now you can take that and go back now to the developers to make sure that that requirement is being fulfilled. And then there are specific types of acceptance testing. That is user acceptance testing. I sit down with the user. And then operational, we want to make sure that it's working well, everything is. And then we have regulatory and compliance. We want to make sure that our system is acceptable in terms of the regulatory standards and the compliance standards, in terms of health, maybe in terms of payments and other regulated systems, and to make sure our system is acceptable in that aspect. Maybe you sit down with the people who are the from those teams of the regulatory teams and analyze their system to see if they meet those standards. Okay, so let's look at the tools. So there are many tools, many different tools that you can use for this acceptance testing to write your test cases, and also some that try to automate this testing. In terms of test case management, you said Zi-Fi for Jira. It helps you integrate Jira where you store requirements, and now Zi-Fi stores your test cases. And then you also want a tool that will help you manage your user feedback. Because you want to see how your users are accepting your software. You want to manage all this feedback that you are getting. That there are tools for that. And then there are also tools for business-driven development. This now helps you the acceptance tests. It helps you bridge business and development. So these are specific tools, and it will depend on the test that you're doing, the specific acceptance test that you're doing, and then also to track the issues that you are also raising. Tools like Jira and also tools like Azure DevOps, they come with user acceptance testing management, where you can integrate these specific test cases into your pipeline. So why it is important, why we want to do user testing? We want to ensure that our business requirements are well. We want to provide traceability. We want to link the requirements with an acceptance criteria. We want to say that yes, these requirements that we captured, it has been actuated. And then to manage user feedback and also enable collaboration. So all this is why these tools are important. The importance of these tools. We want to manage our test cases. We want to manage the feedback that we are getting from the users. And also these tools will simplify your user acceptance testing. So let's move on to now a specific test now called regression testing. Now this is when regression testing ensures that new code changes like bug fixes, enhancements have not broken the existing functionality. Mostly this is done repeatedly throughout the SDLC, especially even after deployments, like when you're doing patches and feature additions. You want to make sure that it does not break the, maybe you're fixing a bug, it does not break the existing functionality. Basically, that's what a regression testing is. So when you're doing regression testing, maybe you want to make a change, you want to ensure that you know which areas will be affected by that change that you want to make. You want to select the test cases that you want to cover. You want to execute the test and then analyze the results that you're getting basically, and then you can add new tests. So this can mostly be done after deployments. During maybe when your system has been deployed, that's when you do maybe a regression testing comes in. You want to fix a bug, you want to do a patch, you want to upgrade something, and that change, maybe it's going to break something. You'll do a test to see that whatever you did, maybe the patch you fixed, it did not affect anything, and everything works well as expected. So it also involves your quality assurance developers, the project managers, automation engineers, and all those people in the team. So let's move. There are also different tools that you can use for regression testing. And since regression testing is something, it is more automated, it is more easily automated, maybe less compared to system testing or maybe integration testing. Regression testing is more easily automated because sometimes it's something that you have done maybe over and over again, and there are different tools that can help you. Again, like Selenium, most of the tools that we have looked before, they can help you also automate such tools. Postman automate such the regression test. You want to see that nothing is breaking after new changes. Okay, now we have looked at all these different tests that are functional for the system: integration, unit test, acceptance testing. Now we have different tests now that are more non-functional, that deals with performance, speed, security, but they are also very important in making sure that our system works well. We have one is performance testing. Again, speed, stability. Want to check the key activities here. Maybe you define the criteria. Again, you might need the environment to be set up, and then you can simulate. You can simulate now, because now maybe in terms of performance, you have to simulate and send traffic to the application. Now simulate such scenarios to see how your system performs. So the benefits, you want to guarantee that the system will offer a smooth user experience. You want to identify any bottlenecks and maybe in performance early and solve that. Maybe any system crashes that you could anticipate could be captured with such testing, a performance testing. And there are tools like load runner, JMeter that you can use to check how your system performs in terms of speed, responsiveness, stability. Oh, yes, so those are challenges you can get. You can be hard to test, to set up these environments. can also be resource intensive, and it requires like realistic test data. So another type of non-functional test is again similar to performance is load and stress testing. You want to push your system beyond maybe a certain limit to see how it recovers. You want to see if you send so many requests. You want to see how that will work, maybe if it will break, and what kind of load your system can handle. Like for example, you want to ensure that your commerce site can handle like 10,000 concurrent shoppers. Maybe you want to ensure that for a specific company or for a specific case, you will have to do maybe a load test to ensure that this specific non-functional non-functional requirements has been ticked. So this also depends on what you're creating. If these aspects are very important in your system that you want to create, you want to make sure that it is resilient and it can handle a lot of load. In that case, your team will have to organize on how to do such a test to see how your system behaves. Okay, so let's move on. Also, and looking at the time and my computer. So again, another one is security testing, which is also non-functional, and also very important. So this is we're checking vulnerabilities, we're doing pen testing. This is now where pen testing comes in, vulnerabilities assessments. These are now you come in and the pen testers, they come and check the vulnerabilities, they send different threats to the system and see how your system behaves. We involve now your security engineers, and different tools now come in like Babsuit, Nessas. There's so many tools that you use for security testing and pen testing, depending on the platform, mobile application, web application. There are different pen testing tools and vulnerability discovery tools for security. And for this, we have to check things like authentication, authorization, data encryption. So these are specific and also very large area when it comes to specific testing for security, which is also a bit complex. It can be time also and resource intensive, and also you can capture. There are now things like false positives and maybe whatever you are capturing the test is just maybe a false alarm, things like that. So it's also a very intensive type of test, and but very most security teams and most softwares don't skip this test because we want to give give the users a system that is secure, and most regulatory compliance I make sure that you do this testing so that you make sure things that the CIA, the confidentiality, integrity, and the authorization and authentication are well done. Most compliance standards require you to do this. And then maybe a final non-functional test is a usability test. And this is now where we have the user experience, the friendliness of the system. Yeah, this now the UX designers want to see how the system feels. Want to see how intuitive it is, how seamless it is to interact with the system actually. So yeah, you can they select users from different demographics, and then they observe, they monitor the way the user are performing these tasks. They want to see how easy is it for a system to a user to just go to your system and do the things they want to do easily without so much instructions. So this is why usability testing comes in again under the non-functional but very important types of tests. And this is a test that is not, you cannot find it being skipped mostly if you want to develop a system that is impactful to the users and that will not be complex and hard to use. It is a system that it's not skipped in most development cycle. The usability testing, and most of the usability testing mostly is manual because we want to observe, want to get the experience from the actual user experience from the people using the system. Okay, so let's look into test automation. So we have talked about writing the test cases. We want to test this. So different tools now can come in to help you automate different test cases. We talked about how unit testing is easy to integrate to your pipelines. It comes with different frameworks because you're testing the smallest units. I also said that regression testing is also easily automated because you're just trying to check if when you do a specific change, you want to check if a specific change breaks the existing functionality. So test automation, you can use it together with manual testing because you can't fully automate all the tests. So it will help you also accelerate the quality and also speed and efficiency. What can be automated, you automate, like the unit tests, and then you'll get consistency and reliability. It will be cost effective. Now you can focus on the test that you can't automate, that you have to do manually. You'll focus on that, and it will give you easy feedback, scalability also, because these frameworks that can automate are easily scalable. And then it also supports the agile and the DevOps way of doing things, because agile and DevOps is all about continuous delivery and iteration, and it comes with a lot of automation because automation drives the fast delivery that we see in DevOps. So you can automate some of these tests, mostly the unit test. You can automate it so that you don't have to be manually checking such small issues, and then you focus on more important tests that you can't automate. So I've talked about integrating test automation and CI/CD integration. Most of the tools that help you automate will help you also integrate the test into your pipeline. So when code is committed to that pipeline, the test is run and you get a report on the specific test case that you want, and then you can go and see where to correct. So integrate with your pipeline, and then you measure the results, and then to check for reliability. So you have the different top test automation tools. The most common is open source. We talked about Selenium, which will help you automate functional and regression tests for web applications. You can integrate with your CI/CD pipeline, and it supports a lot of languages. And also these are other different tools like Appium. All this will help you now after you have your test cases. These tools will help you automate the test cases that are easily automatable. There are many, and these are just a few. There are very many different that offer good documentation in terms of when you want to choose that specific to your project. This PyTest, JUnit for different languages. PyTest is for Python. When you want to write specific tests for unit tests for Python to check your Python functions, your JavaScript functions, these tools will help you automate that and write specific cases and automate those test cases. Also Postman when you want to write test cases for your APIs, to test your backend services and also integrate them into your pipe. When you talk about integrating into the CI/CD pipeline, now it scans when our code base changes, it scans it every time, and it enhances our automation. So we have different best practices when you want to automate our tests. You have to start with the right tests. You want to know which test that is easily automated, so that you don't waste your time trying to automate. So you want to start with the right tests. You have to maintain your test suites, because these tools now they have test suites where you've stored all your test scripts. So you have to maintain it well. You have to check and review and update them from time to time, because now when they run, when it runs, it will run automatically. So you want to make sure that you're keeping an eye on these tests scripts. You want to make sure that you're integrating with your CI/CD. And then shift left is something you've also said. Like, let's say specifically for security, shift left will help you identify will help you identify bugs and issues immediately. They occur in the early stages when the developer is coding. So by the time you're coming to the test stage, you've already dealt with so many bugs and issues, and you don't have to, they have not accumulated in the test phase. It makes sure that you have done a bit of testing in these early stages. Because when you look at the life cycle, the early stages are on the left, and then like now this test phase is more in the right side. So when we say shift left, we are trying to bring a lot of testing to the early stages, so that by the time we come to the last stage, you don't have so much to test, and we have already tested some things and have already fixed some things. And then you have to use reliable data when you're automating, because when you when you don't use the correct data during automation, now you're going to get wrong results from the automation. And then you have to have a balance between manual and automated. I use manual testing for exploratory usability, and then you can use automation for regression and repetitive tests like unit tests. And then you can keep it simple and maintainable. You write modular usable tests, so that it is easy test scripts. So you don't make it too complicated. Okay. So we have generally best practices when doing testing in the SDLC. First, I've said you have to shift left. You have to involve the quality assurance team and the testers. You have to involve them from the very beginning, not just now that we are testing, that you have to involve them. You have to involve them from the very beginning when we are doing our requirement analysis, when you are doing your designing. You have to involve the quality assurance team. When the coders are developing the software, you have to do some testing also there. So don't pile up things in the last stage. In the last test, you say we're going to test everything in the last stage. You have to prioritize. You have to know which requirements you have to test first and prioritize that. The risks and the impacts of the different requirements. You have to prioritize. Maybe you're prioritizing performance, you're prioritizing security. Maybe in this list of requirements, there's the specific requirements that you want. You have to prioritize that it can be now easy when you come to fix, when you want to move forward with your system. And then you maintain clear documentation. Also, in this stage, it needs clear documentation of the feedback that you are getting, of the reports, and then also use automatic automation strategically, like the way we have said. And then you have to have good collaboration between your developers, your operations team, and your testers, your quality assurance people, quality assurance team, the people now mostly involved in this testing stage of the SDLC. Okay, so these are different resources that you can go and go through that gives you really good insights into software testing, how to automate it. These are links. When I share the materials, you can go and check into these notes and documentations about testing. I think I've come to the end. So you can
Thank you, Viola.
have
I mean, sorry.
questions and we can discuss terms, maybe somewhere you've not. And then, yeah,
Oh, okay. I hope Viola, you can hear me clearly.
yes, I can hear you.
Okay. Thank you. Asante sana for the session. That has really been insightful, such a valuable session. Asante, Asante. We really apologize for the hiccups at the start, but we are super grateful that you've been able to promptly resolve those challenges. And then, one thing that maybe I cannot fail to mention that I've learned is that, I think we all know this, or we've had it if we're in the tech space, where it works on my machine, and then someone else says it doesn't work on mine. So maybe the thing, my takeaway has been that all this can be resolved if we shift left. All these problems can be detected early if we involve, the QA from the start, if we start testing from the very beginning. Thank you so much, Viola. We'll now open the floor for questions. We'll take two burning questions because of time. So maybe you could ask your question on the chat. If you'd like to also ask directly, you can raise your hand and then we'll give you the opportunity to ask. Anyone with a question? For those who may not get the chance, we'll leave Viola's details on the chat box, and they will also be shared in the WhatsApp group so that you can contact her. Okay. Any questions? Okay. I'll take that. Take silence means we've all understood. Going once, going twice. All right, cool. So thank you everyone for attending today. Asanteni sana. Before we wrap up, just a quick reminder about Cloudforce Sky community, who we are. So if you want to stay in the loop and also join future webinars or just connect with us at a deeper level, the LinkedIn link has been shared on the chat as well as the WhatsApp group, so you can join. There's also on the LinkedIn page you can find a link, a Google form, where you can fill in some details and then you'll be added into the WhatsApp group. Other than that, any comment from the admin?
Sorry. Let me take that again. Sorry. I'll be very brief. I was not recording on my end. I had muted something. So I was saying thank you so much, Viola, for a presentation well done. And we are looking forward to hosting you again and again. We have really learned a lot. And members will continue to learn even from the group, because we'll be sharing this recording together with the slides. And in case anyone has a question, you will have a way of even reaching out to Viola. She's a very nice person, and she will be more than willing to answer questions from all of us. And also thank you for everyone that was able to be with us from the beginning. I know that we have extended our time slightly, but there is no end to learning. Thank you for taking that time even to be here to learn. Without you, this webinar would not have been possible. And again, also to Rima, our host, thank you so very much for a job well done. And we are looking forward to you and even the other volunteers continuing to host, even as we build leadership among the people who have volunteered with the community. So thank you, everyone. Viola's LinkedIn is shared in the chat, but because you've just rejoined, let me reshare it just now as I'm speaking, so that you don't miss it. Please connect with her on LinkedIn, give her a follow, and then you also follow us. That will be great. So I've shared that. So Rima, back to you. You can end the webinar for us.
I can see a question in the chat.
Oh, yes. Is there a question? Let me see. Yes, there's a question. Maybe you can take that one. Before we end. What's the difference between DevOps and DevSecOps from Collins?
Okay, so right now, we start with DevOps. DevOps is about automating different workflows, fast delivery of software, using now things like CI/CD pipelines, containerization using Docker, things like that, orchestration using Kubernetes. So all these come together to make sure there's continuous integration and continuous delivery of software.
Right.
And fast, and it makes all of this fast. And then now when you come now to DevSecOps, you realize there is something in between there, that is security.
Mm-hmm.
So when you're delivering software fast and you're shipping every day, you can easily forget that you need to secure different things.
Mm-hmm.
So DevSecOps comes in now to make sure that security is catching up with DevOps. And there are different, just like I had mentioned, there are different specific tests that come in when you talk about DevSecOps.
Mm-hmm.
And there are very specific testings that now that are not like the broader picture of this testing that you have talked about. Now you test your code specifically. In terms of DevSecOps, they work with now the developers, to make sure that the developers are developing the software well, they're provisioning the infrastructure safely, and they're developing the code securely, like basically from every line that they write. We want to make sure that security is catching up with DevOps. And as we are shipping our code faster, we're shipping our code securely. Yeah. That is basically what is DevOps, the difference between the two.
Awesome. That is well explained.
Yeah,
Mm-hmm.
it comes with different tools and different concepts. Yeah.
Awesome. So, Collins, I hope you're well answered. Rema, back to you.
All right, thank you, Viola, for the session, for volunteering to share your knowledge with us again and again and again. We are super grateful. Also like to thank everyone who's attended. Special mention for Brian, one who guessed this month's theme. Karibu sana Brian, welcome to Cloudforce Sky. We're glad to have you here. And then lastly, just to thank the Cloudforce Sky community admin. You guys are the glue that keeps this community together. So asanteni for your efforts, for sacrificing your time and your resources just to make Cloudforce Sky happen. So thank you so much. I'd like us to close, and then let's meet in the next session. So, stay curious, keep building, and also remember the goal of this session was to make us aware that testing is not an afterthought. It should be something that we think about from the very beginning. Right. So good night, everyone, and see you on the next one.
Okay, good night, everybody.